Wow! Why is the sand shining?
Did you observe that it is crystalline? Similar to sand grains, salts also have a crystalline structure. Moreover, some salts have a fixed number of water molecules as an essential part of their crystal. These water molecules which form the part of the crystal are called water of crystallization, and such salts are called hydrated salts. For example, in your laboratory, the blue-colored copper sulfate is copper sulfate pentahydrate. When heated, this salt loses its water molecules and its blue color. Let us perform a simple experiment to verify the presence of water molecules in copper sulfate. Take some powdered copper sulfate in a test tube. Hold the test tube with a pair of tongs and heat it using a Bunsen burner. Observe that the blue-colored copper sulfate turns white. When this powder is moistened with water, the blue color reappears.
Do all salts have water molecules in their crystals?
Not all. Only some salts have water molecules in their crystals. For example, sodium carbonate decahydrate, Na2CO3 10H2O. Ferrous sulfate heptahydrate, FeSO4 7H2O. Zinc sulfate heptahydrate, ZnSO4 7H2O. Magnesium sulfate heptahydrate, or Epsom salt, MgSO4 7H2O. Potash alum is a sulfate of potassium and aluminium with 24 water molecules, K2SO4 Al2 SO43 24H2O.
Poor boy! He's hurt himself, and his arm is in a cast.
Do you know what that cast is made of?
No?
It is made of plaster of Paris. Gypsum, when heated to 100 degrees centigrade, forms plaster of Paris, which is chemically called calcium sulfate hemihydrate, CaSO4 half H2O. This calcium sulfate hemihydrate, CaSO4 half H2O, sets and becomes a hard mass when mixed with water. Some of the uses of plaster of Paris are: for setting fractures, since it hardens when mixed with water and sets in a short time; as a fire and waterproofing material; as a sealing agent in the laboratory for sealing air gaps in apparatus where airtight arrangement is required; for making casts for statues, toys and decorative articles; for smoothing wall surfaces;